come back to my YouTube channel. We're still under engineering science info. We'll be dealing with angular motion. You have given these typical questions here. You have given question 2. This is the angular motion. You have given 2.1 says a wheel of a belt drive rotates at 1,500 rests per minute, and the belt is subjected to an effective force of 800 Newton. If the power transmitted by the belt is 50 kilowatts, calculate the diameter of the wheel. I want to calculate the diameter of the wheel. There is 2.1, right? We've given that. So we've given power. What is important you must know. All right, so there, what important you must know, that power is equals to torque multiplied by angular velocity. But now this is our torque. Torque is the same. Remember, torque is the same as force multiplied by R. But now I've given effective force. This will be effective force multiplied by the radius, the angular. Remember, the angular is pi Tn, like this. All right, you understand? It's like that. All right, like that, and then we divide that by the time, whereby might be 6 or what, will depend 2 pi and divide by our time, like this. All right, in this typical problem, so we have here power. All right, so this is what we have. The power, guys, then that time, guys, must be 60. We know that this time must be 60. All right, let me not show, let me just say 60 so that you know, because you 60 if you have given this in rest per minute, but if given in rest per seconds, you don't include that 60. So what do we want here? You've given that, and given the power, you've given the force. It says we want to calculate the diameter of the wheel. All right, with that information, so the power there, want to the diameter, okay, but we have the radius. We know that diameter is 2 pi, radius is 2 times is 2, it's radius, you multiply radius by 2. So I can make r the subject. If I make r the subject, there multiply p multiplied by 60 divided by effective force multiplied by 2 pi n, like this. So we've given that the power it is power 15 kilowatts. So 15 times 10 to the power of 3 multiplied by our 60 divided by effective force, which is, this is it's 800 Newton. It's 800 multiplied by 2 pi. Then what is our speed there? N is 150, 1,500 rests per minute. We have 1,500. So this, if we punch there, get this to be 0,119. Remember, it's in meter. This is a radius, but the diameter is 2 pi r. Then we have that 0,119. You multiply that by 2, simply equals to 0,238 meter. This is how you get your diameter there. All right, you have your diameter now. So that is how you go. So 2.2, we've given the earth as the diameter of this. All right, So it says now calculate 2.2.1 the angular velocity of the tree at the equator. I think, hey, this typical question. They just give you the earth diameter. These people, they're sometimes. Okay, let us try and check something. Yeah, ne, it is funny to become these people who said this paper. They want student to fail. Okay, guys, remember at angle. If we're dealing with angle, we're dealing with something which are rounding, rounding motion, rotating. The earth is rotating. So since it's an angle, you must ask yourself, the earth rotates, rotates, rotate, guys, doing is 360. Rotating, we're talking about 360 degrees. But we know that 360 degrees is equals to 2 pi radians. Rad is 2 pi, is equal to 2 pi in radians. In rads is 2 pi radians. It's rotating. But the time that it took for rotation, which is a day, we know that is 24 hours. We have a 24 hours in the night. The rotation is 20 what? It's 24 hours. The earth rotates 24 hours. 236 by what? 24 hours. So this we have 24 hours in that. All right. That is the earth. You must keep in mind. Then says the angular velocity of the tree that it's on the equator. Where is the equator? Where is the equator? All right. What they want? Angular velocity. Angular velocity. All right, guys. All right. All right. We know that angular velocity is theta divided by t. But now we said theta. Remember, theta is the same as 2 pi. 360 is rotating 360 degrees. Is like a clock. Do you know when you're talking about clock, they can give you a clock which is 2 pi. We'll have this to becomes 2 pi, same as 360. Then the time is making is 24 hours. But we're going to hours to seconds. To minutes, you multiply by 6, will become in minutes. To go to seconds, you multiply by that. So we'll have 24 times 60 times 60. So this will become what in seconds. So punch this, will have 72,722 times 10 to the power of minus 6 rads per second. Okay. That is what we have, guys. That is what we have. That is what we have. All right, rads per seconds. Let me just show you rads per seconds. It's measured in that. Remember this angular velocity in rads per second. 72,722. Okay, multiply by that. So that is what we have. So we have 2.2. Says the angular displacement after 360 seconds. Guys, angular displacement, guys, angular display. They want that. Let me check. What do they want? Angular displacement. Angular displacement. That is angular displacement. Okay, after that, angular displacement. Angular displacement. All right. This is what we have. speed is equal to what? To distance over time. Using this, I can multiply this, will be equals to distance multiplied by this. I'm just checking this formula. Alright, displacement. This is our, what do we have here? Speed multiplied by the time there. So I can relate this to become angle. Now I can say displacement, the one that they are wanting. I can make this, remember this is the speed, I can say angular because now it's rotating. This is a linear, but I want it to rotate, multiply by the time. Can say this is our displacement. So I can, yeah, I've just related that. Take that as a displacement. Now it's what? It's theta. Is theta in this topic. Here it's our displacement. So I'm relating things around here, trying to relate things. Displacement now is theta. Remember the distance, it's the same displacement, we same as theta in this topic. Now as we are relating, as I'm relating that the angular, we have seen that was 72 there on the, we've calculated it, 72,722 times 10 to the power of minus 6 multiply the time is 24. No, not 24. They said 360 second. 360, guys, the same as 60 multiplied by 60. It's the same as 6. You can use that. You can say multiply by in 360 seconds. 3000, or is 3 not 300? 3060 is 300 or 3660, what I'm saying there. So if I punch this, by the way, this is the same as 60 multiplied by 60. So so this will be 0,262 rads, measured in rad. So we have now 2.2.3. Now what do we want? The circumferential velocity in meters per second. Check, this is a linear, it's not longer angle. So we have to use our conversion. Remember to convert, if you want this from angular, we say W. To convert this, you must multiply by the radius. So this will be the linear one, not the angular. This is a linear motion. To convert that, we have this guys, we did calculate here. We started by 8 here on the top here. So I'm taking that there, which is 72,722 multiplied by 10 to the power of what? Of minus 6 times the radius. So we've given the diameter of the earth. Let's check now the radius. Diameter is here. You've given the diameter of 1,274 or 1,274. Okay, 1,274 kilometer. This is same times 10 to the power of what? Of 3. Then we divide this by 2. Alright, so if we divide this by 2, will simply equals to our radius. Divide this by 2, we'll have this to be their radius. Alright, that will be the radius like that. Then now It's a matter of punching. Calculator the linear velocity, punching this. Simply you will give 463,312 must be meters per seconds. So this is what we have there. Our velocity there is 463,312 meters per second. So by the way, so guys, thank you for watching. May you kindly subscribe, do not forget. And then if it's your first time watching my video, please subscribe. As I'm talking to you guys, do not ignore this. Go and subscribe and help me to grow as we grow together. Become the part of the family. I will be keeping on posting some nice content. All the best. Thank you for watching.